This is ROV Visual Modeler version 2012, and currently we're looking at the decision tree module. Now when you start the decision tree or DT module, what you would see is a blank canvas where you can start creating your own decision tree. So let's just get started and see what happens. For instance, if I were to select this beginning cell or node, I can insert a lot of different things. For instance, decisions, uncertainties, or terminal nodes. So for instance, if I insert two levels of uncertainty, that just means, situation or event, first event could occur or the second event could actually occur with some probability. Now I can click on the uncertainty and enter in any type of a decision variable. For example, let's say there's a subsequent decision based on the uncertainty output. Click on that and potentially put another, say, 2 or 3 uncertainty levels, and depending on the uncertainty events that occur, I can enter in terminal nodes. So terminal nodes tend to be, in most situations, triangles. Uncertainty or events that could potentially occur with some probabilities are typically a circle, and squares are your decisions that you're making. So I have 3 decisions in this case to decide which path I want to take, for instance. So this is just a very, very simple way of inserting or creating your decision tree. Now I can click on any of these nodes and drag them around if I wanted to, move them around to wherever looks nice, for instance. So let me click on this and move that around, for instance, just to illustrate. However, if I click on one of these intermediate nodes, when I drag them, what happens is you see all subsequent nodes tend to move together, right? Because that's by default. Or you can right click on this node and you can say move nodes individually. What that means is I can click on this node now and move it individually. All right, but by default, if you right click on it, it should say move nodes together. And so again, I can move any of these nodes, and all subsequent nodes will be moved by moving this single node. So that's a really handy little thing that you can do. The other thing that you can do is I can click on this, right click, or I can just go up to the edit menu. I can copy a node or copy a tree. If I copy a node and paste it, I will only paste that node. If I copy a tree, everything that's subsequent to this node, the whole entire thing will be pasted wherever I decide to paste it at. So that's pretty basic copy and pasting, if you will. Now after you're done with this, you can change the different shapes and colors or different styles. By default, there are several different styles here that you can change to. For instance, we call this fuzzy links. Looks relatively decent. 3-dimensional pictures, hollow point, sprawling 3D. So you can create your own style, by the way, and this is just pure black and white. So let's just go back to the default elegant 3D in this case. So that's looks like a 3-dimensional picture. I can go into any of these nodes, double click on it, and access my node properties. So for instance, I was selecting this node, double clicked on it, I can rename that node. For instance, I can call this, say, the up situation or up condition, whether the market is up or down, whatever it is, and put a value in, say, $100 million in this case, right? And I can also put in a note. I can say, the economy is up in this case, all right? And I can insert the note in this case, either above the note, below the node, or to the right of the node. So let's just choose to the right of the node and see what happens. And you see economy is up in this case. That's my notes. Up is the name of that node, and the value is $100 million. So let me just double click on that, and you can see everything that is that I've just done here. Now sometimes you may or may not want to show certain things. For instance, if I do not want to show any nodes, I can turn this off. If I don't want to show values or names, I can turn certain things off. If I click OK, you see that's gone. So let me double click on that again and bring it back, nodes. All right, very simple to maneuver. It's just a single user interface. I can change the color of those nodes if I wanted to, but typically we'll say leave everything alone the way it is at default. You may, in certain situations, change colors of specific nodes, so it's entirely up to you. We may also put in a branch event name. I'll skip this label inside shape, and I'll use that for a decision node in a minute. But a branch event name, so this is a branch, and we'll call this, let's say good economy. We'll just give it a short and sweet name. We'll call it good, and you can see this is good. And so I can double click on this branch, and I can call this bad if I wanted to, and therefore this is the bad economy. All right, so you see all the values are done this way. I can also double click on this, click on this set simulate assumption. Now by default there's no simulation and no linking. It's just a value that you type in. However, I can click on Set Simulation Assumption, and this is what I get. Now, if you happen to be an ROV risk simulator user, you will know exactly what I'm talking about in terms of running Monte Carlo simulations. So we can actually incorporate Monte Carlo simulation, risk-based simulations, on a decision tree, making this a very powerful tool. So to get started, you can choose one out of the three options here. I can set a simulation assumption where we can use that to run a Monte Carlo simulation. Or I can set an assumption and use it in an equation, or use existing variables that I've already created previously and use that in an equation. So let's just use a very simple situation here, like a simulation assumption. We can name it whatever we want. We'll call it 1, whatever. Choose the probability that you're interested in. There are 45 of these probability distributions, the same ones in Risk Simulator. But let's just choose a triangular distribution, which means high, medium, and low. So I may say, this is 10 million, most likely it's 12 million, and the maximum is 13.5 million, whatever you want to do. Placeholders tend to be just a value, whatever you want to put in there. Really doesn't matter what you have in there. In this case, we may just use the most likely. What we recommend putting some value in, and typically that's just a most likely or average or mean value. All right, and all you need to do is click OK, and we're done. And you see by default it will be checked, and therefore your simulation will be run. You can always uncheck it if you wanted to. Now that is creating a simulation assumption. You can also create a simulation assumption and use it inside an equation. Now we created that one assumption, so SA stands for set assumption. So we have a set assumption, so we know that it's a Monte Carlo simulation. It's a triangular distribution. The min is 10, most likely is 12, and the maximum is 13.5, as we've done previously. So we can reuse this assumption in an equation. So I can say, for instance, 1.25 times SA1 minus 5.6 for some reason, and I can create this as the equation, and the result of this equation after the simulation will be replaced in this node. All right, so that's for a little bit more advanced type of analytics in this case. But for now, we'll just set an input assumption. You can also set an Excel link if you wanted to. I can click on this Excel icon, and I can select an Excel file. I can select an index, a column, for example. So for example, if your data is, there could be 50 data points in column A, for instance. We'll call this, index in column, we'll say column 1 in this case. So what that does is it will tell you which item for you to execute from that Excel worksheet. All right. So in this case, we'll just keep it as simulate, and we'll set that as an assumption, and we'll simulate this, and we'll click OK. And that's all we have to do in this case. All right, very simple. For the uncertainty node, I can double click on this. So once I've inserted an uncertainty node and I've inserted additional terminal nodes, now in this case there are two uncertainty values, or two events, or two situations, a good economy and a bad economy, and you would see an up and a terminal. I have not renamed this, of course. I've only renamed this as up, so you would see the name up here, and terminal in this case is just a terminal location or address. I can give it a probability, let's say 0.3. Click anywhere else, and it will automatically update a complementary value for me, 0.7. I can also set a simulation assumption on this the same way that you saw previously on a probability. So it's entirely up to you, but just be careful, because you cannot set multiple assumptions on all of these outcomes, because in theory, your probability needs to sum up to 100%. So if you set too many assumptions in here, what we will do is we will common size it to 100%, and we will readjust the probabilities for you, and we will use relative probabilities. So the recommendation is you might want to just set one assumption if there are even 2 or 3 or 4 different events or outcomes. So do not set too many assumptions, if you will. Here, similarly, you can set up nodes. I can say show name value nodes, insert a branch, in this case a branch name, same exact situation that we saw previously. All right. For decision node, same thing here. We can set a name. We can ask it to auto compute, because a decision is where we're trying to decide, at which of these branches is the dominant branch, is the right branch to go with, maximizing returns or minimizing costs or whatever it is, or minimizing schedule risk, all those things. So we can typically by default is auto compute. We can also allow it to custom override, which means we force it to take a specific value. but typically we say auto compute, compute the branch for me. You can put notes, and the notes could be above or below. Same situation here, changing colors. And now, typically for a decision node, I can add in a label inside the shape. So in this example, I can say, perhaps this is an oil and gas situation. I can say drill as a decision, and I can click OK in this case. And notice that the name in here, in this cell is drill. So I can resize this if I wanted to make sure that I can see the words, if you will. All right. Simple as that. Now, what you can do at this point is, as we've seen, changing the different styles, backgrounds and so forth, or you can create your own style. Okay, what that means is you can go to shapes and colors. I can change the background color if I wanted to. I can show a grid if I wanted to. So let's just mess around with this just a little bit more. So you can change the colors of that. I can change the connection lines. I can change the decision nodes if I don't like the color of the nodes. If I want to change this to yellow for some reason, and potentially change the font to say size 14, change the color of the font, click OK, and anything else that you're interested in changing. So I can make modifications there. And any changes that you make under shapes and colors will be global in this case. You can apply to all nodes simultaneously. You can apply to current and all new nodes, so that the current node that you selected, or apply to the current node only. I can change the shapes for my decision, but typically it's a square. Let's just use the conventional theory of square being a decision node. So we typically recommend doing that. You can change the different minimum size of the height and the width of this box. So in this case, I have a minimum width and maximum height of 32 pixels and a maximum width of 128. So what that means is I can click on this and I can drag this to 128 pixels, but the height is stuck at 32, min and max. Okay, so play around with that a little bit. You can change text and uncertainty nodes, same situation. I can insert a text in this case. So I can select here, type in my notes, whatever notes you want to type in, aligning left, right, changing the colors and so forth, and that's your text. You can change the size of the text to make it a little bit bigger, a little bit smaller, different colors and so forth and so on. So you get the idea, and there you have it. And of course you can change location of the text and all that. You can also insert a picture if you have some pictures that you want to put in there for some reason. So that's the basics of putting together a decision tree. You can zoom in, zoom out, whatever you wish to do. There are different languages that you can go into. There's going to be 10 to 11 foreign languages. For instance, if I go to something like a simplified Chinese, you would see everything in Chinese in here. So my recommendation is go back and keep your default language, whatever your default language is. So in this case, I will keep English as my default. Alright, so that's the basics of putting together a decision tree. Now, let me open up an example file. If I click on File, Example, I can choose any of these decision trees, but let me choose a basic one. Let's say number 2, market research, expected value, perfect information, and Bayes theorem. That sounds like a very interesting example here. So the decision tree looks like this. In this case, the first decision at this initiation point would be market research. Question is, do I perform market research? So I have two decisions, branches. I do a research, remember this is the branch name, or I do not do a research. Now, if I do not do a research, I need to make a decision immediately. Do I build a small, a medium, or a large facility? So this could be manufacturing, this could be R&D, this could be drilling for oil and gas, big drill, small drills, whatever. It really doesn't matter. So let's say this is building real estate. So a small development, medium versus large development. So I have 3 decisions that I'm looking at. For each of these decisions, the economy could be strong or it could be weak, strong or weak with some probabilities. And if the economy is strong, and if my probability is 80% of being strong, and if I build a small facility, for instance, what happens is I would get a payoff of $8 million. Now, however, if I make the right decision and chose a large facility and the economy is strong, I make $20 million. However, if the economy is weak and I spend a lot of money building the large facility, I actually lose money with a negative $9 million. Okay, so that's the basic setup. Conversely, if I decide to do research, then based on the research, market research, assuming that it is credible, if you will, then there are two outcomes. It could be a favorable research, the results will come back as favorable, or that the market will be unfavorable. Now, if it's favorable, then you have a decision. I can go, again, build small, medium, or large, and again, the economy could be strong or weak in this case. If it is unfavorable, again, there are three levels of decisions: small, medium, or large development. And for each of these, the economy again could be strong or weak. Now, notice that the probabilities have changed in this case because, we're looking at 94% strong versus 6% compared to 35 and 65. And the probabilities here change because we have something called probability updating, or we call that Bayes' theorem. So Bayes updating. What that means is if you don't do any market research beforehand, these are your a priori or your objective probability. This is what I think the market will bear. So regardless of what decision I end up doing, it's still an 80-20 in this case. However, if I do market research, and assuming that the market research is credible, and if the market researchers come back and tell me that it is favorable, that the market will probably be favorable, then the probability that the market is indeed favorable after the market research tells it's favorable is a lot higher probability. Rather than 80-20, it goes up to 94 and 6. Now, if the market researchers come back and tell you that the market is probably unfavorable, then you have a higher probability of a weak economy going forward. So the probabilities will be updated in this case, and we're going to be looking at Bayesian analysis in a second. All right. So here is the model. Very, very simple to set up, and I've put it together with a few notes. I can click on Run in this case. Now let's run without a simulation, and I click on Run, and you would see that this is your optimal path in this case. So assuming, depending on the market research, if market researchers tell you it is favorable, then you should execute a large. If the market researchers tell you it's unfavorable, you should go with medium in this case. That will get you the highest bang for the buck, the highest expected value. And you can actually see what the values will be. $18.26 million compared to $8.15 million in this case. That's the highest value. 7.35, 8.15, and 1.115. In this case, 7.94, 13, and 18.26. So again, when you click Run, you can make that decision. Now, if this happens to be not payoff benefits, but let's say it's cost or time, something that's negative, what you can do is highlight the path with the minimum value instead of the maximum value. Okay, so very, very easy to do. You can also run a simulation. I've set up a simulation in this model. So let's just run it at 10,000 times and click on Run. And you see at the bottom here, it says simulation is running. Please wait. And the simulation is done. So it took about 3 seconds to run 10,000 simulation trials in this case. So whatever assumptions that I have set up, so let's say this was a simulation assumption and this was a normal distribution. So that node actually simulated. So we can click on the summary of values, and you can see the decision nodes, uncertainty, and terminal nodes, and you can see the names and the IDs. The IDs are the locations of each of these, each of these cells, if you will. So we can make a lot of different changes to here. Let's take a look right here and go back to summary of values, and you can see terminal nodes, uncertainty nodes, and decision nodes. So this is just a summary of the inputs and the outputs. We can click on simulation modeling. I ran 10,000 simulation trials. You can look at the mean, the median, all of your 4 moments, your skewness, your kurtosis. I can do a 2-tail, left tail, right tail. Let's just say we do 2 tails, and if I do 5 here, and let's do a 95%. So what that means is this is a 90% confidence. So this is the 5% line, this is the 95% line. So the probability between these two lines would be 90%, 5% on the left, 5% on the right. So the expected value 90% of the time would be have a confidence interval between 14.73 and 17.17 million dollars in this case. Or I can do a left tail versus a right tail, and I can say what is the probability of it being, let's say, at $15 million. Okay, so I can change any of these values if I wanted to. All right, and just override it and type in any type of numbers here. Okay, and you will be able to calculate your values and the probabilities of events. You can copy the charts, you can paste it anywhere you want to, and it should work flawlessly when you are pasting into, like, say, PowerPoint or Microsoft Word. You can also look at input probabilities. Here are all the probabilities as there. Here's your payoff tables. So that's your analysis result as well. We can also go into Bayesian analysis, so Bayesian updating. I would recommend reading through the examples here and clicking on something like load example, and this would be a very basic example that you can get started with. So for instance, you can look at this decision variable. The first uncertainty, we call it A, and we have a second uncertainty. So, read through this, figure out the favorable versus unfavorable. This is just a quick getting started guide, so we don't really have time to go into the details of Bayesian updating and Bayesian probability, joint marginal probabilities, posterior updated probabilities. But suffice it to say, everything that you need is right here, and the user manual should be able to get you started in terms of learning what Bayes' theorem actually does. But briefly, what Bayes' theorem does is whenever you have a sequence of uncertainties, in this case, where one is linked to another, in this case, so small compared to this favorable, medium to this favorable, there is some updating, probability updating, compared to we just have small, medium, and large, and there's no probability before it. Okay, so this is called conditional joint probabilities or probability updating. All right, so we can do a Bayes analysis there. We can do EVPI, expected value of perfect information. You can load some examples, go through, the details here, read through it. Minimax, max-min, minimizing the maximum regret. Risk profiles, and here's just different strategy risk profiles. We can run sensitivity analysis, scenario tables, and do some utility functions as well. So again, this is a very, very quick and dirty example of how to get started with the software tool. Now, to get into the theory, into the discussions of all this, you would have to refer to the user manual for a little bit, or some of our more advanced, modeling videos. So this, again, is just a quick and dirty getting started guide. So you can also click on help, by the way, look at the user manual, resources that's online. You can click on install license, and when you click on that, you will be given a hardware fingerprint. Hardware fingerprint is pretty much an 8-digit alphanumeric value that is specific to your computer. So every single computer out there has, multiple components like a hard drive, like a motherboard, BIOS, and so forth. And all of these different elements have their own serial numbers. So we take 5 of these elements, create our own serial calculation, our own algorithms, and we come up with a hardware fingerprint. So all you need to do is email us your hardware fingerprint, and we will generate for you a name and a license key that you can type in, and you will be able to activate the license in this case. So very, very simple to do. You can change the different, if you make changes to the background, decisions, terminal, and so forth, I can click on manage styles, and I can add or save a current style, delete a style, and so you can add style number 11, number 12, number 13, or create your own set of styles if you wanted to. Properties, we've seen that. Global options, you can play around with that. Simulation options to see which path you want to highlight, a number of previous files you want to show on the file link, in this case a list of recent files. You can also protect this file if you wanted to and give it a password with 256-bit encryption, so nobody else would be able to open your file except with the correct password. So that's the basics, if you will. And 2 additional little things here: a tool window and a property window. Property window is, for example, if I select this cell right here or this node, you actually see all the properties and you can make changes to it directly. Rather than having to double click on this and obtain the user interface, you can actually now show the property windows, click on any of these, and be able to enter in any type of inputs like names, branch name, comments, different colors, and so forth. So pretty much what we've seen previously. So that's the high-level basics of looking at decision tree module of ROV Visual Modeler 2012.